So hey everyone, in this session, we'll be talking about AWS Cloud Security. So using AWS, you can gain the control and the confidence you need to securely run your business with the most flexible and secure cloud computing environment available today. As an AWS customer, you will benefit from the AWS data centers and a network architected to protect your information, identity, application, and devices. With AWS, you can improve your ability to meet core security and compliance requirements like data locality, protection, and confidentiality with the AWS services and features. Thus, AWS allows you to automate the manual security task so that you can shift your focus to scaling and innovating your business. Plus, you don't have to pay upfront. You just have to pay for the services that you use. All the customers will benefit from AWS being the only commercial cloud provider that has its service offering and associated supply chain vetted and accepted as secure enough for top secret workload. The benefits of AWS security are you can scale securely with superior visibility and control. You can automate and reduce disk with deeply integrated services. You can build with the highest standards for privacy and data security. You have the largest ecosystem of security partners and solutions. And finally, you can inherit the most comprehensive security and compliance controls. In short, you have multiple options to secure your infrastructure through AWS. We will be walking through multiple services of AWS, which are going to help us in the security part of AWS, in which we'll be talking about multiple services or modules of AWS, which will include Artifact, Certificate Manager, Cognito, Detective, Firewall, Guard Duty, IAM, Inspector, KMS, Macy, Firewall, Secrets Manager, and WAF and Shield. So to get started with the most basic things inside AWS, let's assume that I have a web server and this web server is working on my Apache web server. We will be using this as our code base to show how securities can be implemented inside my AWS infrastructure. Plus, we will be doing it in multiple ways. We'll be creating a web server using our Apache web server, and the same we would be doing inside our Docker also. So for that, let's get started. So what we'll do is, first of all, we'll start with our EC2 servers. We'll go ahead and launch two instances inside our Apache. So we will go and take a T3A small instance, let's assume. And just because I also want to enable my security for port number 80 or for my HTTP, I will also enable port number 80. Port number 22 is enabled at the moment because I want to enable SSH connectivity. So review and launch, and let's get through the connections. But before that, let's just go and create two instances. So here, launching, acknowledge, and let's launch the instance. And let's wait for the instance to be booted up. This instance, we will call it as Apache. And this instance, we will call it as Docker. Note, both the instances are created inside 1C. However, it doesn't matter much because your security is applied at the VPC level and generally not at the subnet level. But that is not to say you cannot create. You can also create the infrastructure inside your or the security inside your private subnets also. So let's just wait for some time until my instances are up. Okay, now that the instances are up, let's start and make a connection with those instances and start our web servers. For that, I'll be doing a SSH connection on my machines. So what I'll do is I'll just use a terminal to go and create the servers inside the two machines. First of all, we'll start with our Apache web server. Then we'll start with our Docker server. Right now, inside Docker, I don't have anything, but eventually, if we have it, we can go and take help of it. So first, let's go and do an update on the servers. Okay, next up, let's go and also install our Apache web server inside the same. Now, this means that my Apache web server inside my instance 1 has been created. Let's go and test it out. We indeed see my Apache to Ubuntu default page coming up over here. Just to verify that this is my Apache web server, we'll just go and modify some content of this specific file, and let's call it by something as Apache web server. Now, if I go and refresh my page, I should see on the top Apache web server, which is indeed the thing that we wanted to see. We don't need this anymore. We can very safely exit it. Next up, let's go and install Docker and go and do the same thing using our Docker. The only purpose to do this is we want to see security both inside my EC2 instances as well as my Docker instances. This also is going to be the base of our complete security, because to view security or to understand security, you at least need to have some servers in front of you. This is what our base is going to be. So now what I'll do is I'll just go and run an image of Docker, and we will run it in detached mode. If everything is good, I should see my Apache web server running inside my Docker instance also. So if everything is good, let's go to our instance 2. Have a look at the IP address, and indeed this also tells me that the container is running or my web server is running. These two terminals are no longer required, so we can very safely go and remove them. So this is my instance 1 and this is my instance 2. Both the instances have web servers running inside them. Let's get started with the security part. First way to ensure that the instances are working or are secured from the outer world is via ensuring that at least the SSH connectivity or the way to connect with your Unix instance is disabled. For that, what we can do is we have something known as a security group. As you can see, security group basically decides if a machine should be connected to the internet or not, or to any port or not. Because I do not want anyone to connect with my instance, for that reason, what we can do is we can go and remove our security from port number 22. That will ensure no one can do a SSH on my machines. To work on that, let's go to the security group, click on edit inbound rules and remove this specific thing. So if I click on save rules now, and now if I want to go and connect with my instance via instance connect, or via any other way, we just have to go and click on connect. Eventually, we will realize that we are unable to make a connection with the machine. The reason for that is no one can go ahead and do SSH because the security group is blocking. This is the first way to block the users from accessing your servers. The same thing, let's try to do it on the Docker machine. If I click on connect over here, this again is going to error out because my SSH is disabled. On the contrary, if I go ahead and enable port number 22, I can do a SSH on my machine. For instance, let's just go and enable port number 22. Now, if I go to my instances, connect, instance, connect, I should be able to connect with my instance like I am now. Similar thing with my Docker server, basically. That is just to tell you that it's not important that it only works with your normal EC2 instances. The same thing can work with your Docker container also, or you can go ahead and call it as the Kubernetes pod or the cluster as well. So in this case, as you can see, I am unable, or rather I am able to connect with my machine on port number 22. So first thing that you want to do is you want to go ahead and block your port number 22 so that at least no one can go and access your servers over SSH. Secondly, you might or might not want to go and enable or disable the traffic on port number 80 because you see at the end of the day, this all is a web server in itself. So you generally do not want to go and stop port number 80. Just in case you want to do that, you can very well do that also. To get into that, let's do a thing. Let's go ahead and start to work on our load balancers. So what we'll do is we'll go ahead and create a load balancer or an application load balancer. Let's call it as ALB-1, which is connected to 1A, 1B, and 1C. It has a security group of its own. We will come back to this one shortly, which is working on port number 80. It has to forward to a target group. Because I do not have a target group as of now, I'll go ahead and create one. Because I am working on an application load balancer, it gives me instances, IP, Lambda, and ALB itself. This, by the way, is one of the major differences between your ALBs versus NLBs also, or the major difference between your application load balancer and your network load balancer. A ALB can forward to a Lambda function also, whereas a NLP or a network load balancer cannot. So what I will do is I'll just go ahead and select the instances. Let's call it as ALB-servers. We will enable it on port number 80. And let's go and next select both the instances, include as pending, and create target group. Once it is done, you see a warning over here, none associated. And the reason for that is you have just created a target group. A target group at the end of the day is nothing but a collection of multiple machines. So this target group over here, we'll go ahead and attach it to our load balancer. I don't see anything. The reason is refresh, and you should see your web servers coming up, and click on create load balancer. Now, if everything is good, in some time, if you try to hit this specific DNS, you should see your load balancer coming up, which in turn should also forward your request either to machine 1 or to machine 2, how the load balancers are supposed to work. Remember, we haven't added security until now. We are going to start with the securities after my load balancer becomes live. So let's just wait until this goes into active state. Right now, it is in your provisioning state. This might take some time depending on the basic health checks of your load balancer. So for that, you can always go to your target group. You can go to your monitoring. In ideal scenarios, you should always see the load balancers as the complete. So over here, I see healthy S2, which means indeed my load balancer should almost be up and running. If you want to go ahead and modify that, you can always go to your health check and you can go and increase or decrease the timeouts or the ports by in the same way what we have decided or discussed inside our load balancers. So anyways, if I go to my load balancer now, you see it tells me it works, and if I refresh it, it gives me this page. Please note it is giving me two different pages. Sometimes it's giving me web server 1, sometimes it's giving me web server 2, and exactly that is what my load balancer is also supposed to do. It is supposed to route my traffic to two or multiple instances. Ideally, one instance at a time, it can go and forward it to n number of instances at any point of time. Okay, so if my load balancer is all good, now let's go and start to add the security at my instance level. So what I want to do actually is this load balancer, or these instances rather, are connected to instance ending in F2FE. This one is also F2FE, which means if I go ahead and change port number 80 of any one of them, I have removed 80 also, and I have removed 22 also, which means no one can make a connectivity with my machine. The problem now happens is that means my load balancer also cannot make a connectivity with my specific instance. And that you see is the problem for me. Right now, if I do this, it's going to give me the classic 504 error, which stands for gateway timeout. The next time you see this error when you are working on a load balancer, in very simple term, it means load balancer is trying to hit the instances and the instances themselves are not responding. To fix this, what we will do is, see, anyways, I cannot go and enable port number 80 for any IP address. That is not the secure way. I do not want to do that. Elsewise, anyone can go in and make a connection. So what I am going to do now is I do understand my load balancers over here, or load balancer or my application load balancer is connected to a security group. Which security group? Which is ending in O3A3. Next, what I will do is I'll go to my instances. I will open the security group of my instance. I will edit the rule and I will say just allow port number 80 from one security group, which is this. And I will click on save rules. If I do this now, ideally, I should see my load balancer forwarding me to a specific web server. Pay attention to certain things. My EC2 instances, no one can make any connection with my instance either via SSH or via port number 80. However, my load balancers themselves can make a connection with my EC2 instances. And only the load balancers can make a connection with my EC2 instance, because I have created the rules in such a way that port number 80 is only allowed from this specific load balancer. This is one way of doing it. The next way might have been you would have attached your load balancer to a specific security group. Let's call it as SG1. And you can also attach the same thing to another load balancer. Let's call it SG2. And we can go and attach our instances to the same security group. What I mean to say is my load balancer and my two instances are all part of the same security group, and all the traffic between the same security group is allowed. That is another way of doing it. You are going to see whenever you talk about security in your organizations, you are going to see one of these two ways. Ideally, this is the best way because you have ensured no one can make a connection with the machines, including you. Now, next thing, supposedly I want to make a connectivity with the machine because I want to modify anything. What will I do? In reality, we do not go and modify the security group because you see, if you are going modifying the security group, editing it, adding port number 22 and giving your IP address or any IP address, then you are anyhow failing the first thing that you wanted to do inside your servers, which was I want to stop anyone from accessing, including me. In this case, what we do is we go to the instances. From the instance, I create a AMI by going to image. I can either create an image or a template. I create an image. From that image, which is a AMI, I create a new instance. I make the changes inside that new instance. From that new instance, I go ahead and create another AMI, and that AMI I can use either in a auto scaling group or I can use it as a standalone instance itself. You can expand it to your ECR, ECS, and EKS as well. The concept remains the same. So this is the first and the most easiest way to say that my instances are secured and how to add security inside your EC2 instances. Next part. Going back, this is my load balancer. So I'll just leave this page as it is because we will be going and refreshing this multiple times to ensure that whether this was successfully happening or not. What I will do is let's go to our VPC or virtual private cloud and talk about NACLs or network access control list. In short, NACLs have the access to both allow as well as block any specific port or set of port or protocols. Security group can only allow. However, if you want to go ahead and block something, you can take help of NACL or Network Access Control List. But the important thing with NACLs are two. First, NACL will work at specific subnet levels. You see, this NACL is associated with a specific subnet. More about it, you have already seen inside your previous VPC class, so we won't be repeating that. However, if you want to add your own NACLs, you can very well do it. The only thing is you will have to go and attach a VPC, and then you will have to create a network ACL, and next you will have to go and add your subnets association yourself or add the subnets yourself. If you do it, it will be added. If you do not do it, it will be automatically added inside the NACL, which was created when you created the VPC. This is also known as the default NACL. The same concept, by the way, also will apply inside your route tables. We are going to talk about that also shortly. But before that, because we have already talked about security group, let's talk about NACL. So going back to my instances, I see my instance are associated to a VPC, and that VPC is 3775F, which means obviously I need to take the VPC which is associated with 3775F, which means I need to work on this NACL. Going back and refreshing the page over here, I see that it is forwarding me to one of the traffic. And just note, for a brief period of time, it might even forward you to your instance inside your Docker machine. For instance, if I open it on a new tab, there is a very big probability that I will be forwarded to any one of them. See, refresh the page. One time it is telling you EC2 instance, one time Docker instance, once EC2, one Docker, and so on. That is just to tell you that your EC2 and Docker instances associated with the load balancers can work simultaneously. Sometimes you might think or you might hear a statement where it is said that Docker and the containers cannot work, or Docker and the instances cannot work simultaneously. We are seeing an example of that. Once it forwards to my EC2, next time it forwards to my Docker. Anyways, I know that this thing is pretty much working. So let's go to our NACL, and I was talking about this NACL, and let's go to inbound rule, and let's just go and add a new rule with priority 90, where I will just go ahead and block port number 80. If I do this and I refresh my page now, you will start to see this will go ahead and it will not open up anything, which means this is method number 2 to stop or add security to your instances. Right now, we are just talking about blocking the ports, but this has some wider implications. Consider you are working on MongoDB port number 27017, you can block from the outer world. You are working on MySQL port number 3306. You are working on MS SQL port number 1433. Whatever ports you want to block, you can block it from your NACL level itself, just by going ahead and creating a specific rule which will simply say deny. NACL, by the way, if you are giving for inbound, you will also have to give for outbound. I am not giving it as of now because inbound, anyhow, if I am blocking 80, I know outbound anyhow is going to be blocked. To fix it, let's go ahead and just either allow it over here or just go ahead and remove the rule. If you do this and you just go ahead and refresh the page, you are going to see the same thing back again, which means this is method number 2, how to secure my instances via NACL and security group. Next method. So again, let's refresh it to see everything is working. Indeed, I have already understood security, NACL, and security group. This security is the default inside your VPC. Next up, you can also go and modify some things inside your route table. The important thing is to understand which VPC I want to do it in. Sometimes you might do the error that you are working and you did make some changes, but you see it's not reflecting. A very common use case for that is that in this case, you are working on VPC 1 and the settings that you are modifying are in VPC 2. Very commonly it happens. So that is why we personally open the AWS console and we check the VPC. So I know that it is ending in 3775F, which means if I go ahead to my route tables, I also understand that I am only connected via my internet gateway, which means if I go ahead and remove my internet gateways or my subnet associations for my VPC, again, it should not work. Let's go and do a proof of it. So I click on edit routes and I just remove the internet gateway and I click on save changes. Now, again, if I refresh the page, it will again start to block because obviously, the internet gateway is not available or not connected with my VPC, or rather, my route table entries for the internet gateways are not available. So, like we just discussed in the previous session, we understand that our internet gateway is pretty important, and more than that, my route table is important because that defines the entries for what all network traffic is allowed. So going back to fix it again, let's go ahead and just add my internet gateway over here. And let's go and give the address, which is 0000/0, simply stands for any IP address in this world, which means if I go ahead and refresh the page, I should again see my web page coming up or my load balancer responding. So we do understand we have multiple ways we can go for security over here, in which case we can take help of ACL and security group. We can take help of internet gateways, and we can even block it at the route table levels. Generally speaking, this all happens at the security group level or at the NACL levels in general. This is first part. EC2 security. Now let's go for the next thing. So when I say that my EC2 servers are all created or my servers are created, the server data is actually saved inside my volumes or inside my EBS. My volumes are over here, which is my volume, which is GP2. This GP2 volume or the storage that I have can also be encrypted. In my case right now, it says encryption is not available. This is not the thing that we generally want to see. We always want to ensure that encryption is enabled for my instances. When I say instances, I do not mean the hardware or the CPUs or the RAM of my instance. Rather, I am talking about the data which is present inside the instances, which means EBS or Elastic Block Store. So how to encrypt the data inside my volumes is the second part of security that we are going to talk about. And the service that we will be talking about here will be our KMS or Key Management Service. So let's get started with it. First thing, my volume at the moment is not encrypted. If at all I want to encrypt it now, I can always go and modify the volume, but I don't see anything in encryption. On the other hand, I can choose over here and I can. So going back, if just in case we want to go ahead and encrypt my volume, there is no way after a volume has been created that I can go and encrypt my specific volume. However, while creating the instance, I did have the option. I could have selected my instance, storage, I could have chosen a encryption key. Let's go ahead and just launch this instance and let's call it as a dummy instance. And we'll also see, is there any difference when we try to log into this instance? Let's call it as encrypted instance. So this is also a T2. This one is a T2 instance, the free instance. If I go to this instance and I go to my volumes over here, and in some time, once the instance is up, I should see my volume. The difference that you are going to see is over here, the encryption will say as encrypted. And it will also give you a KMS key ID and the key alias name over here. This volume says encrypted. That means whatever data is inside my volume at that moment obviously is all encrypted, which also means that is this instance different in any way? Let's test it out. I click on connect over here and it gives me an error that this instance does not have a public IPv4 address. So if in case it doesn't have a public IPv4 address, it will tell me. If I still want to connect, you can always click on connect over here. And if everything is good, you should see the connection coming up. So if I give who am I, it tells me that you are Ubuntu and your private IP is 172.168.3.150. Going back to my instance over here, this private IP is 172.168.3.150. What you should pay attention in this one is it does not matter if your instance is encrypted or not. From your perspective, the instance is going to look the same. The only place where you can figure out if actually the instance or rather if the volumes are encrypted is by going inside my volumes and going to my either encryption over here will say encrypted, or you can scroll right and it will tell you encrypted over here, or for the second and the third volume it is telling you not encrypted. So this is method number one by which you can encrypt your data inside your volume. There is one other method also by which you can click on create volume and you can choose to encrypt the volume and you can choose whatever key you want to create or you want to use while encrypting. This key will be used for encryption and the same key will also be used for decryption. Same key can be used for your EBS volume and the same key can also be used for your snapshot encryptions. In short, if you want to go ahead and encrypt any of the volumes or data, that can be done via the keys which are present inside your KMS. which brings us to our KMS or AWS Key Management Services. Using KMS, you can go and manage and store your keys. You can generate the keys inside KMS or you can even import the keys. The keys can be used for both encryption and decryption. The important thing is the keys which are inside KMS will never leave KMS. So you can be assured that your data can never be decrypted outside KMS or without using the services of KMS. KMS will or KMS is the only place where your encryption is actually kept. So what we can do here is we'll go ahead and create a key. So for that, we click on next over here. We give the key name as key-1 and let's call it as encryption key-1. Next step, I can choose the administrator who is going to use this key. In the next step, I can tell who is the administrator of this key. By the way, I can also choose another user or another account who can manage this specific key also. Next, you just have to go and click on finish and this key is enabled for you or is created for you. This key can be used to encrypt, including EC2. So if you click on launch instance now over here and you select, let's say Ubuntu Server 20 instance storage, and you click on key, you are going to see the same key coming up here. Earlier, you only saw the key of EBS. Now you have key-1 here also. By the same logic, if you go ahead and click on volume and you click on create volume and you select encryption, again, you will have the option of key-1 over here. This is your key. Again, if you want to go ahead and create your snapshot and you want to encrypt that snapshot, that can also be done. So let's say I am creating this snapshot and I am giving whatever description I want, that can also be encrypted using the same key. So basically, if you have created a volume, you can encrypt it via two keys. Either it can be AWS key that AWS created by default for you, or it can be the key that you created yourself inside your KMS console. The important part here is key over here cannot be deleted as it is. You would have understood the reason by now, which is if you are deleting the key, that basically means anyone who is using the key cannot use the key anymore. That is why AWS will not allow you to directly go ahead and delete the key. Rather, you will have the option to schedule the key deletion. Minimum wait period is 7 days. So even in case you want to delete the key upfront, you cannot do it. You will at least have to wait for 7 days before you can go ahead and delete the key. Next up, let's go ahead and talk about encryption. We have done. Now, if key is not required, you can go ahead and delete it. Remember, AWS KMS will charge you for A, creating the key, B, for encryption as well as decryption of the key. So this is almost a free service or some part of it, or if you are choosing it, it can be free, but only up to a specific limit. To know more, you can always go for AWS KMS and pricing, and you can visit the page where it is going to tell you about the pricing. So basically, let's select the region as Mumbai for us. For each 10,000 requests, you will be charged 3 cents. After 10,000, you will be charged for this much. So based on that, AWS is going to charge you. So remember, KMS is not a free service. You can create as many keys as you want, but each key that you create, if it is doing the encryption or the decryption, is chargeable for you for whatever you are creating. This symmetric and asymmetric is when you had created the key, it would have asked you whether you want to create a symmetric key or a asymmetric key. Assuming you do not need the key anymore, you can always go ahead and schedule the key deletion. For in my case, I am scheduling it for 7 days. In 7 days, the key will be disabled or deleted, which means if I go ahead and create a volume over here and I decide to encrypt the volume, now if I select the key, this key is still available with me, and so it will be for the next 7 days. This is how you can create the instances, stop the instances at the networking level itself, and B, you can go ahead and encrypt the data that is inside your instances. In the previous sessions, we have already talked about our Lifecycle Manager, which basically means that whatever data I am having inside my EBS, I want to encrypt all the data while I am creating a specific policy. In this case, you can name it based on whatever names you have or whatever tags you have. You can give any policy name as per whatever is required. So if you click on next over here and okay, over here, click on add and next. In this case, you can go ahead and create whatever schedule you want. Apart from that, you can also go ahead and encrypt whatever keys you have. So this is about my EC2 encryption. Next, let's go to our S3 service. From S3 service, we will navigate to our Macy service also, which is also a security service inside AWS. So let's talk about AWS Security and Macy. So for that, let's go back and create a bucket over here. Let's call this bucket as APR 2022 inside Mumbai. I am enabling the ACLs. I am unblocking all the public access and I acknowledge and I am clicking on create bucket. If a bucket by that name already exists, you cannot create, which means you will have to create a bucket by a unique name. In my case, I am creating it by bucket April 2022. This also exists bucket in. So if the bucket has been created, it should show up over here. Next up, let's just go and upload some data inside my bucket. So what I'll do is I'll just go ahead and upload my data of Bangalore bucket. And let's go to the images and just get a picture. So if it is done, let's go ahead and upload my picture inside the bucket and let's go and make it public. And now let's understand about the security of my S3 bucket. First thing, let's go inside my object over here and look at the object URL. And if I try to open the URL, it is going to show me the image that I uploaded inside my S3 bucket. Now, in the use case where you feel that this object should be available for public view or public access, in that case, you can create the bucket as public and the object as public. Now you have a specific requirement where you say, I do not want my bucket or rather my object to be public. So in case you just don't want your object to be public, in that case, you can just go to your objects over here, click on the permissions over here, and you can just go and remove the read access and click on save changes. Doing this, if you go ahead and refresh the page now, it is going to give you access denied. And the reason for that is the object itself has been created as a private object. To nullify it, let's go to the permission again, edit and give the read access on my object and save changes. Now, if I go ahead and refresh the page, I should see my bucket or my object as public object now. Let's just refresh the page once and come back to the image. And Okay. Refreshing the page is going to give me the same image again. So this is another way to protect your sensitive data inside your AWS S3. But this is happening at the object level. What if I want to stop it at the bucket level itself? In that case, I can always go to my permission and either I can block all the public access, in which case if I do confirm, remember my object was still public. If I go ahead and refresh, it gives me access denied because now the bucket itself has become a private bucket, or rather I have blocked all the public access. If I remove this and I go ahead and refresh the page, I should again see the same image coming back. Next step, we can also go down and enable the ACLs or disable the ACLs. For instance, if I give this access, this very simply means anyone can go and view anything inside the bucket. And this is generally something that you never want to see. Whenever AWS starts to give you a warning like this, where it says publicly accessible, it means the bucket is available for anyone to be viewed. We generally do never want that. That is why it is also giving you a warning over here. It can be accessed anywhere, and AWS ideally tells you that you should never have this setting inside your bucket. Means anyone can go and view the data of your bucket or any object of my bucket as they can right now. So how do we fix this? For this, AWS gives you multiple options. First, if you go inside your buckets and you just go for creation date, it is going to give you a big warning up front here itself that this bucket is a public bucket. Assuming I do not understand it from here, in that case, AWS gives me another service, something known as Messi. Messi basically is the service of AWS which can automatically go and tell you if there is any sensitive data inside your buckets that should ideally be in private buckets, or is there any data that is being exposed over the internet or over S3 that should not be exposed. You do not have to go inside S3 ever and do all these changes or check for the buckets. Though at max you will have 100 or 200 buckets, you can very well go and have a look at the access level itself to understand. But assuming you do not want to do that, in that case, you just have to go and enable Messi. AWS security services, like we said in the beginning, are generally created in such way that there is very minimal interactions that are required from your perspective. For instance, if I had to go and discover and protect the sensitive data inside Messi, I just had to click on Get Started, enable Messi, and that's pretty much it. Messi is automatically going to go and tell me if at all there is any problem inside my bucket. I just went on summary and it is telling me that yes, 7 buckets are publicly accessible. Over here, what are the buckets? This bucket that I created some time back is also coming up over here, which it says was created 3 minutes ago. The bucket is inside Mumbai. This happens to be the ARN, and this bucket is publicly accessible. Here itself, Messi is telling you that there are these 2, 3, 4, 5, 6, and 7 buckets that are actually created as public buckets. So you want to go ahead and do something on your own, you can always go and click on remove over here. You can click on whatever buckets you want and you can go and create your own specific filters also. Messi, as you see, is automatically doing everything for you. Next up, Messi can also help you. So analyzing buckets, we don't know. We do understand analyzing the public buckets. Messi can automatically tell you if there is any bucket which is a public bucket. But there is a bucket that has some sensitive data. For example, your UID, your SSID, your Aadhaar number, these or any data that is inside these buckets are sensitive data. You want to go ahead and tell what data inside the buckets are sensitive. You just have to go and click on get things started, analyze bucket, create job, and go ahead and create and tell when do you want to run it. You want to run this every day, or the client is telling you weekly or monthly, just tell it what date do you want to start. If it is weekly, Monday every week or Sunday every week, or maybe you want to run it daily. And if it is a one time job, you can do that. I want to go ahead and view all the objects. Then if I have any specific identifier, I can do that. Identifier is something like you can give Aadhaar number, your photographs, and so on. Next up, let's call it as a identify hyphen sensitive hyphen data. And let's say this job will run once and tell about the sensitive data. Next, this is going to be the cost that AWS S3 is charging you if in case you are going to go and run this specific job. Like every service of AWS, AWS is not doing this for free. The reason is AWS understands that there are 14,300 objects. This is the size which AWS Macy doesn't understand is this. This is compressed, this is uncompressed, and whatever ratio you want to go ahead and compress. So basically, whatever you give, that much is going to go inside compressed and uncompressed. Have a look. 1x is pretty less, 3x just 2 times more than that, and 5x is exactly 4 times of that. So basically, it is telling you that indeed I can go and run this specific job inside my Macy. I can also tell you that how much I am going to charge you. And at the end of the day, I will also tell you if there is any data inside Macy that ideally should or is a protected data. From your perspective, you just have to go and click on submit, and Macy is going to go ahead and do the job for you. Now, if you make it 1x or 3x the compression ratio, this bill will actually go up or down. And based on whatever jobs you have created, if at all there was any job, it is going to show you inside the bucket, inside the type, and using the jobs. From your perspective, you just have to go and work on Amazon Macy, and it is going to tell you if there is any classifiable data or any protected data inside your S3 bucket. While we speak, AWS does have the plan of introducing a service like Macy inside your Elastic Block Store or inside your volumes. However, it has not been done as of now. The reason for that is using this service, AWS is actually going and reading all of your data, which certain companies would not prefer. So that is also a reason why you generally do not want to go and enable Macy inside S3 buckets. Though if you have too much of data, like a million records or something, you can always go and enable Macy. This is about my S3, how I can go and block access, or even if I have given the access, I can figure it out using my Macy service. Also, AWS also gives you access for the public access settings for the account, which simply put means that if you go and block all the public at this account level, then all the buckets which are inside this account will by default not have the public access for all of them. This is your AWS S3 and how you can protect the data inside your buckets. Next up, let's go to our next service of AWS, which is IAM, or Identity and Access Management. Like we have already seen inside IAM, I can go and create specific users, those who are going to go and access specific services of AWS. These specific services of AWS will be dependent on whatever user you have created, and if at all they have the access for your specific services. So let's go ahead and create a specific user. For example, let's call it as user-s3. And let's go and give them a custom password. And we are removing the access for removing the password at sign on. Next, we are simply giving them the access to my S3 bucket completely, and I click on create user. Now, assuming this user has signed in to my AWS account, and I want to know what all things this user has done. Apart from that, this user has signed into my AWS account and I want them only to go and access your S3 service itself, only S3 service. That anyhow is pretty easy because we have only given them access to S3, which means if you want to apply security at your user account level, the service that you want to work around is your IAM. The services that we are going to discuss now are going to revolve around IAM and CloudTrail. IAM is to give the access. CloudTrail, on the other hand, is to go and select or view that what all access has been given to what all users and what all are they doing from what all IP addresses. Let's jump into this and see it for ourselves. So what I will be doing is I'll just be opening it inside the incognito window because elsewise AWS is going to log me out because I would be working from two different accounts. So let's just go and copy the username and let's log in into this with user and whatever password I have created. If everything is good, AWS is going to go and give me this user. Just note this user over here was in my name. This user over here, on the other hand, is having user -s3 at the rate of whatever account ID we had. What we will do is we'll just go and navigate to our home region of Mumbai, and we will just go ahead and change our service to Amazon S3. If I go for Amazon S3 at the moment, this is telling me that my total storage is this, object count is this, and the object size is this. This you had also seen inside your MISI. Going back, let's go ahead and delete the bucket that we created some time back, which is over here. And if I click on delete, it will not allow me. The reason is first I will have to empty the bucket. So just in case, if there is a use case where the bucket was deleted without the objects being deleted or removed, that is not possible inside S3. So what I will do is I will just click on empty over here and I will choose permanently delete. And next I'll go ahead and delete the bucket itself. The bucket name is my whatever bucket name we have given over here. So this user has now deleted the bucket, which means somehow there should be a place inside AWS which is actually keeping a log of who deleted the bucket. The next thing inside security is a user. So if I have to protect my AWS infrastructure from external services or actors, I have MESI, I have security group, I have NACLs, I have firewall, I have inspector, I have detective, I have multiple services to do that. But what if something is happening from internal to my AWS account? How will I ever figure that out? The answer is IAM and CloudTrail. First of all, let's go to our CloudTrail service, or rather, let's go to any generic service of AWS like EC2. Now, if I go to EC2, it gives me a generic error where it says API error. And the reason for API error is because I have the new EC2 console. If I go for the old EC2 console, I see this error and it tells me that nothing is running or you are not authorized to perform this operation. As you would have guessed it by now, the reason is my user only had access to S3, right? It didn't have access to IAM. But just to prove it, let's go back to our root account. Let's click on close, open the user, and let's give them access to EC2 as well. So what I will do is I'll go add permissions, attach policy, and give them access to EC2, let's say, and add the permissions. Which means if this all is good, if I go back to my instances and I refresh the page, I should see the instances coming up over here. And I do see them. I do see the instances, which means if I modify the permissions over here, I can actually go and view the instances, or I can go ahead and work on the instances also. Which means if by chance I go ahead and delete my instance or terminate the instance, my instance is gone, which means again, in some time, AWS should tell me that my instance was deleted by this specific user. Generally, it happens if you go and allocate the permission immediately. A general advice for you is go and refresh the page or log out and log in. The reason is, as you would have seen inside the screen, it tells you you are not authorized. But the moment you go and refresh your page by doing a Control R on Windows or Command R on Mac, this basically refreshes and it will show you. Okay, so this, let's leave it over here for the time being, which means if this user is actually working on that specific instance, at least there should be some place where it tells me or displays the same information to me. And it is. It is telling you this user last did it some time back, last signed in at this time back, and this user is actually working inside your AWS console at the moment. But what are they actually doing? For that, multiple ways are there. Either go inside your username and go to your access advisor, where it is going to tell you all the things that this user is doing as of now. So this is one place where the user is working on. Next service is your Cloud Trail. So right now I am from the root account, but you can very well be from the administrator account or from the AWS Cloud Developer or the DevOps account as well. So if I go to Cloud Trail over here and I go and view my events, it is telling me that yes, a console login happened where this user logged inside S3. But now the confusion will start. You do not see anything as delete bucket or delete instance or terminate instance. And the reason for that is the region matters. You are inside North Virginia. Move the region to Mumbai. Remember, the instance and the bucket both were in Mumbai. So the cloud trail has to be inside Mumbai. If I go ahead and do that, it is telling me that indeed a delete bucket happened. And who did it? User -s3 did it. What was the bucket name? This was the bucket name. And similarly, a delete or terminate instance happened. Which instance? This instance. Though this is not the only thing that AWS is going to tell you, it is going to tell you a lot more than that. For that, you can just click on that specific event, and it is telling you that indeed this user actually went ahead and deleted your instance. Earlier, it was into running state. After the user deleted, it went into shutting down state, or the user instance or the instance was actually deleted. And the same is the case with my delete bucket also. So who did it? User S3 did it. At what time they did? This time. From what region? This one. What was the access key? This. They had done this inside your S3. They did the delete bucket. This is the unique event ID for you. And the IP address from which they did was this. By the way, if I go ahead and type my IP address over here, it is going to give me the same IP address, 122.167, this and this. So basically, this is the IP address from where the delete operation actually happened. So this is a way by which you can go and tell which user did what inside what all services of AWS. Now, just in case if you were wondering that if a user actually deleted a bucket, I can always go ahead and figure out inside CloudTrail But is there a service by which AWS could have told me or given me a warning that this particular resource or bucket is getting deleted? And indeed, there happens to be a service. So we have something known as Amazon Events Bridge. Inside your events bridge, you can go and create a rule in which you can go and create a rule. So let's call it as delete hyphen bucket rule. Description is, let's say, this rule will be triggered when a bucket is deleted. And this will happen whenever my S3 service of AWS or S3, not in, it can be inside Outpost or it can be inside AWS itself, and my bucket level operation, and inside my bucket a specific operation which actually is delete bucket is triggered. So just in case if my S3 delete bucket happens, I can go ahead and send this to my SNS topic or to my notification topic, the same thing that we have discussed earlier. In that case, if I click on next and I click on next and I go ahead and create a rule, in that case, AWS Events Bridge can prompt you or tell you via email or via your SNS subscriptions, which can include email and phone number, that yes, indeed, this bucket was deleted. Now, next step, you will go inside your cloud trail and figure out who actually deleted that specific bucket. So this is a way by which you can again know who did what inside your AWS service. Moving ahead, we understand that we have something as IAM management console. And then basically, if we go ahead and allocate the resources, we can always go and ensure that the resources are working only on those specific services. Now, there is also something known as a permission boundary. So let's go ahead and have a look at it. This also is an advanced feature. So permission boundary is basically the maximum that this user can do inside that specific AWS account. So my user has access to EC2 and S3, and my permission boundary is set to S3 itself, which means if my user tries to go ahead and run anything inside my instance, it will again start erroring out. Permission boundary is a advanced things, and the reason for that is permission boundary is the maximum that this user can do. You can allocate whatever permissions you want over here, but permission boundary will ensure that at max what you can work on is your S3 itself. By that logic, if my user, even though they have access to S3 and EC2, but if the user tries to go and run anything over here, it will start to error out and it will say you are not authorized to perform this operation. On the contrary, going inside my service of S3 is going to work the same way as it was working until now. So this is another way by which you can go ahead and create the security policies for the users using your boundary conditions also. So why not only give them access? Yes, you can give them the access using your policies. You could have even given them the access using the groups, and the groups themselves were attached to those specific policies. But let's assume I have a group of 100 individuals, and those 100 individuals are working on a specific service, and I want to give only specific access to those specific individuals. For that, I can take help of permission boundaries. So going back, if the user is not required, we can always go ahead and delete the users as over here. So we can go and now, so if I go ahead and just open this user at the moment and I open any of the surveys, it's obviously going to error out because the user doesn't exist. Refreshing the page will say session has expired, and in short, I cannot access anything inside my AWS account. Okay, so let's move to the next service of security inside our AWS. So we have already seen our IAM and we have seen our artifact and certificate manager. Let's go for the ACM or Amazon Certificate Manager. In short, you want your data to be encrypted when it is hitting your servers or your load balancers. Basically, the data between you and the server should all be encrypted. For that, you can go ahead and take the help of your ACM or Amazon Certificate Manager. So what happens inside ACM is you can always go and request for the certificate. Next step, you will have to go and give your domain, like let's say Ankit, my domain, which is this. And then let's give something like this. Then you have two options, either for the DNS validations or for the email validation. You can choose any one of them. If in case you have route 53 in place, you can just click on request, and if the certificate and everything is good, the certificate will be issued to you. In that case, you will always have to go and click on create records inside route 53, and if everything is good, the certificate should be issued for you. Like I have the certificate over here, which automatically has been issued to me and is created until March 1, 2022. It was created and it will expire almost after 13 months. So if it was created on March 1, 2022, it will expire on April 1, 2023. So this is ACM for you, or Amazon Certificate Manager, using which you can go ahead and secure the data which is moving or going inside your load balancers or inside your EC2 or inside your clusters. Next up is my AWS Firewall Manager, Guard Duty, and Inspector. So let's get started with our Guard Duty. Guard Duty basically is the service inside AWS that can do the threat protection for accounts and the workloads. In this case, we just have to click on Get Started and enable Guard Duty, and that's pretty much it. Guard Duty is automatically going to tell you if at all there is any problem inside your AWS account, or rather anyone who should not be accessing your service is actually accessing your services. Let's go and have a look at it. For example, here I can go and give something known as a list. Here I have two options. I have a trusted IP list and I have a threat list. Inside the trusted IP list, I am going to go ahead and talk about the IP address that are whitelisted IPs, or on whom my address or traffic is actually enabled. While on the threat list, I can add any malicious IP, which means if I go ahead and add anything inside my malicious IP list, then in that case, that IP should not be able to access my AWS services. Next, what we'll be doing is we will be going and talking about a trusted IP list and a threat list, and we are going to see how AWS Guard Duty is going to protect my infrastructure using these lists. So continuing with our list management, here we can add two types of IP addresses. One is the trusted IP address and one is the threat list. For the threat list, what you have to do is you will have to add a threat list. The concept here is that either you can add a file of CSV format or you can add it as a plain text, but you cannot just go ahead. It's not like a text box where you can go ahead and add any data inside your threat list. What you have to do is you have to go ahead and create a text file. That text file you have to place inside your S3 bucket, and that S3 bucket location you have to give over there. So let's get started with that. So what we'll be doing is we'll be going ahead and creating a text file for us, and that text file in turn is going to go ahead and be uploaded to my S3 bucket, and that location we are going to add as the threat list over here. So that's what we are going to do. So for that, let's go ahead and create a text file for ourselves. So what we will do is, in this case, I just have a file over here. Let's go and add a IP address. So what I'll do is I'll just go and add my IP address to this list. For instance, this, and as you know, as we have seen in the VPC class, because I want a specific IP address, it can be /32. If I'm looking for multiple IP address, I can just go and separate it something like this. If it's in a range, I can even go ahead and do something like, let's say 25 or 24, 23, based on the CIDR blocks, whatever I have. So this IP range you can go ahead and add. So let's go ahead and save it inside the desktop, and let's call it as threatlist.txt. Next up, we'll have to go and upload this file to our S3 bucket. For that, we'll go ahead and choose a bucket. Let's take this one where I have the key pair, and let's just go ahead and take the file of our threat list and upload it to my bucket and upload. And that should pretty much be it. So next, now, if I go ahead and just get my object URL, I have to go to the threat list. I have to give it a list. So let's call it as threat list -1, give the location, tell that this is actually a plain text file, and I agree and click on add list. Now, the only thing that you have to do is to place it as active, which in short means that now if you are trying to open up any of the servers or any of the IPs, AWS is going to go ahead and give you a prompt. So for instance, over here right now, I have seen, or looking at this itself, AWS is telling me that based from this IP address, this user tried to go ahead and did something at this specific time inside this specific region. Now, if the user is actually trying to log in into this service or trying to perform any activity on this service or any of the AWS services, AWS is going to go ahead and tell me about those also. So in some time, we should be seeing this all policies or this all services actually getting populated. The important thing is that this service is also available for multiple other services also, like you have S3 protection enabled for your guard duty. So basically in this case, you don't have to do much. Guard duty is automatically taking care of the security if in case there is any unauthorized access, or AWS or guard duty understands that there might be any unauthorized access. In that case, it is going to show up to you inside the findings over here itself. So that is how guard duty actually works. Next thing, if you want to have a look at the pricing, that how much is guard duty actually charging me, you can go and do it based on either your CloudTrail logs, which we have already discussed, or on the case of your VPC Flow Logs. You see, VPC Flow Logs is inside VPC, and whatever data is flowing inside your VPC, if you want to monitor that or you want to go and log that, you can always take help of Flow Logs. So what you have to do is you just have to go select your VPC, select your flow logs, click on create flow log, give it a name like, let's say, log-1. You can select the accepted traffic, rejected traffic, or all the traffic. Aggregation, you can put whatever you want. The logs will either be saved inside your CloudWatch or inside your S3 bucket. If it's your S3 bucket, you can just go ahead and give the location of that S3 bucket. If it's a CloudWatch log, you can go ahead and give that. And if you have log, like in my case, we have multiple logs, you can just go ahead and select that, which basically means that if in case you had selected your CloudWatch service, going inside your CloudWatch service, inside your log service, you would have seen your logs over here. For example, for me, for the Fargate instances inside my ECS, if I go down, I am going to see multiple logs which were created on this specific date. I can always navigate and I can always figure out that what exactly was happening inside my cluster. Looking at this, we can understand that a Docker server started, or a Docker process started, which was working on Node.js on port 8080. So that is how log groups are pretty important for us, because looking at this itself, we can go ahead and understand the logs of whatever things are inside my network. So if in case you want to select any one of them, you can always go and select the CloudWatch logs based on whatever you see over here. The same thing comes up here also. The important thing is the region. If your VPC is in this region, the CloudWatch logs should also be of the same region. So in this case, if you go ahead and create it, AWS is going to save the logs of the traffic in or out of your network of VPC, which it is going to save inside something known as a flow log. Next up, this is your VPC flow logs basically. So whatever flow logs are inside your machines or whatever AWS is finding out, it is showing you here. So for example, you can see it is telling me that indeed a API is trying to, or someone is trying to access my bucket. Which bucket? This bucket created by Lambda on 5th March. It is being done by this IP from this location, latitude and the longitude, and this is the ISP. So it will tell you at the level of your broadband provider based on your location, based on your city, and based on your IP address. So this is how good or how AWS will actually go and tell you that who is trying to access what in what all location. If you remember, inside my AWS S3 keys itself, I had actually gone and created my threat list.txt file. So inside this bucket itself, I created this particular file. So what AWS is telling that this file had a IP address, and that was my IP address. Looking at this itself, I understand that this IP is trying to go and open up certain services of AWS inside your account, which it is showing you over here. So basically, guard duty, as you can see, automatically takes care and it will automatically tell you all the events which are happening inside your AWS account from whatever blacklisted IP you have given. Next up comes up my AWS Detective. So in this case, again, as we can work with guard duty, similarly, we can work with Detective also. Detective is a service of AWS inside your security. You can go ahead and have a look at Detective also. Like the name suggests, it is going to go and tell you what problem inside what all regions and why is that problem actually occurring. Like in this case, we have, as we would have understood by now, it goes and takes help of Flowlog for VPC, AWS CloudTrail for IAM and whatever things were being accessed, and my guard duty to go and have a look at what all services were being accessed from my malicious IP. In this case, you just have to go click on this button, investigate with detective, and it is telling you multiple things. For this account, for this user, at this IP address, there is some issue. And the issue is this bucket is being accessed. So this is how good or how fast guard duty will actually go and tell you if at all there is any problem or any blacklisted IP is trying to access your AWS account. It is based on the priorities also. You can have the priority as low, you can have the priority as high, or priority as medium. If you don't segregate, AWS is automatically going to do the segregation for you. Usage, we have already seen about the pricing. First month initially is free. After that, AWS is going to charge you based on whatever you are using this service. List, we have already seen. Similar to our blacklisted IP, we can also go ahead and add the whitelisted IP, which is also known as your trusted IP list. In this case, any request from this specific IP address will not be shown to you inside your findings over here. This thing is important because if you start to see multiple IPs over here, you generally don't want to see the request from the servers, which are your own authenticated servers or which are the servers of your organization. So similar to what we did for our threat list, we will also be doing it for our trusted IP list. Next up is my Kubernetes protection. In this case, again, whatever logs are present for Kubernetes, you don't have to go and maintain any sort of, it means if you want AWS to maintain it for you, AWS can automatically do it using Kubernetes protection itself. Next up, you have your accounts, basically whatever account. So let's say you have or you are working on multiple AWS accounts at the same time. In that case, if you want to add multiple accounts that has to be monitored via guard duty, you just have to go and give the account ID and the email address of that specific account. You also have the option of uploading the list or the CSV file. You can always download and have a look at the format. General format will always be account ID and email, where you will have to give the account ID and the email, and you will just have to go and upload that specific file. As this is a CSV file, the delimiter in this case is going to be a comma operator. Next up, if you want, you can also go and have a look at what's new. Generally, whatever services AWS is adding in whatever new region, guard duty is generally enabled in those regions. Also, you can click on Mumbai region and you can see that guard duty by default is enabled on all the regions, which basically means that if you enable it in a specific region, by default, it should be enabled for all the other regions also. So going back, this has been my guard duty service inside AWS, wherein I can go and access, or I can go and give the protection services of AWS to AWS itself. To monitor the resources, I can always take help of my detective, which is going to tell me and show me the fine details of the services. Next up, let's go to our security and talk about our security hub. Security hub is the service of AWS, which is just going to go and combine all the services that we had earlier, namely guard duty, for the threat list and the whitelist, inspector to understand what event exactly occurred, and Amazon Macy to understand about my S3. So in this case, if you just go to your security hub and you just enable your security hub, AWS is automatically going to go read the logs of your guard duty, inspector, Macy. So what it does is it will go and read the logs. And if at all there is a problem with any of your services, it's going to tell you inside the customized dashboard. So let's go ahead and just enable Security Hub, which basically is going to give me the practices. So let it run for some time. What will happen now is that Insights is going to tell me if at all there is a problem with these services. It can be multiple services. It can be something like AWS resources, if any bucket has an issue, if any AMI has an issue, if any S3 bucket is not meeting the standards, and so on. There are multiple policies by AWS themselves. Next, if AWS is getting any issue or finding any issue, in that case, AWS is also going to show you. Remember, all of this is being fetched from a service on which this was already enabled. Now, because you have guard duty enabled inside your account yourself, you can see that it is telling that a severity medium from my guard duty from a IP address a minute ago was accessed, or this service in short was accessed. So in that case, if you go to this particular service, it will also tell you that from this specific IP, this specific place, this specific service was being accessed. So you can have a look at it yourself to understand that from this IP, this which is present in threat list 1, unauthorized access is going on. So you can go ahead and take a action on that yourself. This, by the way, can also be integrated by multiple services of AWS. And not only AWS, by the way, it can also be integrated by tools like Jira. So if in case your company has it has Jira, or it has something as Ops Genie, which is a tool of Atlassian. Jira also is, by the way, is a tool of Atlassian itself, or you are working on any of these services, you just have to go and click on accept findings over here. In that case, you will have to go and purchase a subscription. You will have to follow whatever is inside configure, which generally is next, next, next. And if you go ahead and do this, in short, if at all AWS gets or follows any error inside your account, for example, 5 over here, it is going to tell you on the provider wherever you have configured it. In short, you again do not have to do anything. Rather, AWS Security Hub is automatically telling you all about the services and what all security issues are present inside the service at that moment. You can always go ahead and either remove the Security Hub if you don't need it. In that case, remember, Security Hub will not charge you because Security Hub will charge you for the initial 30 days. If you are removing it before that, AWS is not going to charge you. So this is one of the most important services of AWS, which was my Security Hub, followed by my WAF and Shield. WAF and Shield, in short, will go and configure my servers in such a way so that if in case I want to go and block certain IPs or I want to unblock certain IPs, I can do that easily using my WAF or my web application firewall. Let's take an example of it. Let's go ahead and create a IP set over here. So let's call it as IP-block-1. Let's call it as, and my region over here, I am looking, it can be global also if you want. For me, because I'm in Mumbai, I'll just give my IP address, and my IP address happens to be this. And create IP set. If in case it is a problem, it will tell you, it is telling you that the reason is that this IP address should be in CIDR format. So let's go and give it /32. If it is done, it is going to go and show you your, so right now it doesn't show me, the reason is I am in North Virginia. Let's move to Mumbai and it will show me my ID, which is inside Mumbai. So this IP set, what I have done is, if in case I want to block anything or unblock anything, I can take help of my IP set over here. This also can include multiple IP lists because you might want to create certain IP sets for your production environment and certain other for your test environment and UAT environment. Next up, you just have to go and create something known as a rule group. For instance, let's call it as block IP, whatever metrics you have inside the region. Then you can go and add a rule. So let's call it as block. And if it matches the inspection, whatever it is, so let's say if it originates from a country in or has label is or originates from the IP in whatever IP set we have. If this happens, in that case, you have to block it. You can even put count. You can even put a CAPTCHA in that case, just like you have the normal CAPTCHA, those events are going to trigger and you can just click on add rule. This is for 1. This priority is 1. And next you just have to go ahead and create a rule group. If you do this, now if this rule is in place and someone tries to go ahead and open anything from this specific IP address, it is going to give them an error and it's also going to tell you the count, how many times it actually blocked. So this is what is meant by my WAF or web application firewall. By the way, if you want, you can also go ahead and give a HTML text. So let's say, let's give it something like blocked, and let's go and take a sample HTML hello world page. This can also be JSON if you want. It can be a plain text also, it can be HTML. So let's just go ahead and take a sample HTML page and let's give it over here. And let's say, sorry, this service is not available in your region. You might have seen something like this when you were trying to open certain websites. This is actually what happens behind the hood. You actually can even block it from your route 53 also, and as well as your normal AWS service of rules or WAF also. If you click on save over here, that very simply means if someone tries to go and open it from any of the IP addresses that you have given inside the IP set over here, in that case, it is going to go ahead and give you the block address. So everything is going to get blocked, whatever is in this IP set. You might have the requirement that you want to go ahead and add multiple IP addresses. That can also be done by going to add IP addresses, or rather you can go and put multiple IP sets over there itself. This is a way to do that. Next up is your Web Acl, which we have already discussed, where we can go and create a Web Acl. So let's call it as, let's say, ELB-block, and description, let's say this will just, let's go and confirm the region first of all, because this service WAF is a global service. So you will have to ensure that you are working inside that specific region only where you want to create the service at. So what we'll go ahead and we are working on AP South 1 from here also. We see it from here also. So we'll just go ahead and create a Web ACL. So let's call it as block-ELB, and description inside Mumbai. Any associated AWS resource, if you have, you can give that. For example, I have a load balancer already. In this case, let's go ahead and this is for my application load balancer. Next up, if you have any rule, you can go and add a rule. That rule can be something as what you created earlier. Let it come up. So AWS managed rule or GeoGuard or any of the rules you can go ahead and give. In that case, bot control, IP reputation, anonymous IP. So basically it simply means that these all applications cannot go and open that specific service. So if this is all good, if it doesn't matches, you have to block it, click on next, and you can go and enable this. So if you go ahead and create a Web ACL, this in short again means that if at all anyone is trying to open up your ALB or your application load balancer from that specific service or from any endpoint, it is going to block. This is another way to stop your application at your ALB or application load balancer itself. So this does take some time. Let us wait for it to get completed. Now, if at all this thing is all working, let's go back to our EC2 and just run a quick test to ensure that indeed these things are actually working. First thing, let's go for a public IP. Now the public IP doesn't give me any response, and that is pretty much understood. As you would have seen in the previous class or in the previous session, my security group itself wasn't allowing anything. And anyways, the rule that I have created is for WAF. In that case, if I go for my application load balancer and I go for my this load balancer, ideally earlier this was all working. But if I open it now, it is going to give me an error as forbidden. And the reason why it is giving me forbidden, as you would have guessed, is because your WAF is actually blocking it. Which also means that just in case if you happen to remove this rule, then this should again start to work in some time. So let it happen is another resource. Okay, so why you cannot delete it? The answer is pretty straightforward, because you are working on block ELB, which is working on these IP addresses. So as you can see, these all IP addresses, I am trying to open it at this specific time and it is blocking me. So if I just go ahead and just keep a note of 0502, okay, if I go ahead and refresh it again, the last was at 00502. Now, if I go ahead and have a look at it, it will tell me that 0502, it was already there. These all IPs have been blocked, which very simply means that anyone originating from this IP will actually have the error of forbidden. You might have seen this error on certain websites where it says that you are not authorized to view this specific website. This is another service of AWS that can help you with that, which is your Web Application Firewall version 2. You can also go ahead and create your rules for bot also if required. In that case, bot control simply means that if there is a application like the advertisement or SEO, like the bots which will continuously hit your servers, you can also take some action based on that also. In that case, by default, Web Acl has bot controlled enabled in itself. You just have to go and click on add WAF control rule group, and you just have to go and tell that what all bots you want to stop. Remember, these all services are managed by AWS themselves, and for that reason, they are chargeable by AWS themselves. So this is about your security inside your AWS, wherein you can go and secure your services through IAM. You can go and secure your services through CloudTrail, go and watch CloudWatch or have a look at CloudWatch logs. Then you could have gone inside your various security services like encryption via ACM. You could have gone and went inside your AWS firewall manager, like the application load balancer we talked about, guard duty to stop services from accessing your AWS account, IAM to manage the resources, inspector to manage your EC2 instances, key management services to encrypt your data using the keys that you created, Macy to tell you or warn you about any vulnerable data inside your S3 bucket, and finally AWS Network Firewall to block, which apparently is the same as your AWS Firewall Manager itself, Network Firewall and the Firewall Manager. Finally, going down to my Security Hub, which basically is the combination of my multiple services. It will just tell me about the findings, and WAF and Shield, which is the same as my AWS Firewall Manager. Last thing that we are going to talk about is our Inspector, which is a service free for initial 15 days. Inspector basically works inside your EC2 services. So what you have to do is you just have to go and enable the network assessment and the host assessment. Network assessment doesn't require you to go and install Inspector agent like we have already discussed in our IAM sessions earlier. You need to go ahead and create a policy and install a specific software known as Amazon Inspector Agent. Inspector agent, if you want, you can always open the link, and this is going to tell you how to install it inside multiple machines. In case you are working on Linux, you just have to go and run 1, 2, and sudo bash installs, and that's pretty much it. It should automatically install. Now, to ensure that this inspector has the access, you will have to go and create the corresponding roles for it, which again is present inside my systems manager run command. So in case you just want to go ahead and get a look at your network to understand how are the networks actually, or how is the network inside my EC2, you can take help of network assessment. If you want to go ahead and have a look at the vulnerable softwares and security best practices inside your EC2 instances, you can always take help of your host assessments, which in case is going to run your inspector agent inside your EC2 and give you the comments, or the same way as we did it inside our earlier services. Inspector is going to tell you the findings over here, which are going to be segregated as per the rules and the priorities that you have selected. This is all about AWS security. I will see you in the next one.